Right, so the other one. When a mixture of N2O4 and NO2, so this is typical an example that we used to study in the equilibrium, chemical equilibrium, when you study KP. So in equilibrium in a closed system, at a given temperature is cooled, the concentration of NO2 increase. So this is normally the equilibrium that is present here. So the enthalpy is more or less endothermic. So what is going to happen here is, so I will go with the second one. The dissociation of N2O4 to NO2 is an exothermic process. So normally this is not an exothermic process. This is an endothermic process. So this is wrong actually. And what is happening when the temperature effect is done? So normally this is endothermic. So this is like the cooling procedure that we normally discuss. And the backward reaction is heating. Okay, so you drop the temperature, you are cooling the system, you try to cool. So what is going to happen? The heating procedure should happen. So the heating procedure is the backward reaction. So more and more N2O4 will be forming when you drop the temperature. The other way is when you heat the system. So when you heat the system means you are going to increase the temperature and you are heating. So when you are heating, what is going to happen? According to Le principle, the system starts to cool down. So the forward reaction happens and more NO2 will be produced. Okay, so this is a typical reaction that we normally discuss in our class. Okay, so when a mixture of N2O4 in equilibrium in a closed system at a given temperature is cooled, so you are cooling, the concentration of NO2 increases. No, when you are cooling, heating process happens, so more and more N2O4 forms, NO2 concentration decreases. Okay, so this is wrong, this is wrong, the answer is fine. So if you don't know whether this reaction is exothermic or endothermic, get the knowledge from here. That's all I can tell. Okay. Because this should be a reaction that you should have discussed in your theory class.